Hello everybody. Welcome to this breakout session on how to guarantee unified communications over your network and more generally application performance guarantees, looking beyond traditional WAN optimization techniques to guarantee unified communications, collaboration, ERP, CRM and software as a service performance. My name's Mark Burton. I'm Vice President of Strategic Alliances at IPANEMA Technologies, and it's my pleasure to be presenting today. Okay, so let's begin by considering the challenges faced by enterprises in their day-to-day business. Businesses are driven by efficiency, and this typically comes from using applications that run across a network, so it's important to make sure that the network can perform to deliver the business efficiency that's required. That, of course, is not as easy as some people might think. Business drivers, such as mergers and acquisitions, productivity, innovation, and cost savings initiatives, lead to IT transformations such as cloud, software as a service, big data applications, and of course our favourites of things like collaboration and unified communications, all of which touch customers and end users of the services and of course the underlying IT that runs the business. What does this mean? IT and network resources get more and more loaded and are really also expected to perform better to deliver the services, and of course normally we have to do this at a lower cost as well. So if we actually drill into the figures, it's quite surprising to find in a survey we ran last year that 79% of CIOs have found out that organizations suffer from application performance problems. That's a lot of people who are struggling to manage their networked environments. Problems are, perhaps unsurprisingly, increasing in frequency. And of course, they tend to affect key services disproportionately for a variety of reasons. People complain more about important applications anyway because they use them more. And of course, things like UCC and the key applications that you already run on your network have very stringent performance requirements, which means that it's easier for them to be perceived to be going wrong when new things occur in the networked environment or when you roll out a new application that increases the load on the network. Surprisingly, perhaps, when enterprises increase the bandwidth and the budget applied to the network, in actual fact, in a lot of occasions, the problems remain. In our survey, we found only 20% of organizations that increased bandwidth were able to say they'd successfully addressed their performance problems with their applications. So bandwidth is not the only problem that's faced when you roll out a unified communications service. What does it mean when we say application performance problem? Well, that's an interesting question. According to Network World in 2013, that actually equated to 73% of organizations seeing a real decrease in productivity for their users of their applications. Clearly, that's not what we want to see when we're deploying collaboration tools in unified communications. This impacts customer satisfaction. It increases the number of complaints about the network, the applications, the cost of doing business. And of course, it makes it much harder for users and organizations to actually get their work done effectively on time and in budget. Well, when we look at modern applications and networks, it's not a surprise, even though we've been building networks for 50 years, to find that application performance can be impacted when you add new stuff into the environment. Modern IT is hugely complex, as are the networks that we've built to enable the services that run across them. We've got things like in-house or outsourced data centers. We've got public cloud, private cloud, hybrid cloud applications. There's software as a service, platform and infrastructure as a service. And then we've got different ways of delivering the network. Things like 4G, LTE, MPLS, internet, wired access, Wi-Fi access, the list goes on. And at each point in the delivery chain, it's important to be able to manage the performance and the access to the resources to be able to guarantee that the applications you care about get the service that they need. Let's break this down a little into the core business components. What is it that we set out to achieve when we build an IT infrastructure? Well, at the high level, the business just wants stuff to work. Somebody may well have decided to run a unified communications collaboration project to optimize their travel budget, to enable people to hold video conferences rather than get on aeroplanes. This is quite a common thing that we find in the market. And that business decision is taken at a very high level. But of course, as you push that down into the enterprise, we actually have the traditional applications that run over the network that need to continue to be serviced when you're rolling out your new unified communications infrastructure. So we need to protect unified communications, but we also need to protect the other new uses in the network, such as cloud applications, the old uses in the network, the ERP and CRM systems we all have. And of course, we need to control access to things like social media, because particularly at the moment with the Olympics, it's very easy for people to stream the curling or ice dance or whatever it happens to be that your country is in at the moment. And you can really kill your network performance when 20 people are watching the Olympics and one guy is trying to make a telephone call. So it's a challenge in a networked environment. What does that mean? IT has to deliver services while, in fact, taking advantage of all of the resources that are available to them. It's no longer acceptable to have backup networks that exist only to take activity in times of disaster recovery. We regularly talk to organizations where the financial director says, why do I have 2 accesses and only one of them is used? Why can't I use them both and not buy more bandwidth? This is a very sensible question. So we need to be able to use all of the resources that are available to us. We need to be able to get transparent, seamless operations. And we really need to start moving into the world of IT governance, being able to demonstrate that the applications the business relies on work appropriately for the users that are using them. And of course, we need to do this at a reduced cost point or an optimized cost point, because budgets are always tight in IT. Now, it's fair to say that this isn't a new challenge. This challenge has been around for a while, and in fact, a lot of organizations will have built tool sets themselves to address some or all of the points of the challenges. What does that mean? Well, you may well have gone out and purchased or written or got for free some applications to help you with visibility, what's going on the routers, to help you with setting up quality of service. You may deploy some application delivery controllers to make your websites work better. You could upgrade bandwidth when you see a link that's busy. There are a lot of tactical things that can be done to try and improve performance in the network and to try and understand how the network's being used. But the more point products that we put in place, really the more the complexity of the management environment, the higher the cost just to run the management environment. And actually, when you look at a lot of the tools that you have, they tend to compete with each other over what they do. A lot of applications will be polling the same things. You may deploy WAN optimization and classes of service, and the two can actually compete, because if you WAN optimize some traffic and you don't make sure that it's completely set up correctly, you could put it in the wrong class of service and not get the performance you require. So it's very easy to have competition in the tool sets that you've got to make the situation better. Now, clearly, of course, that is not a good thing. So how do we move beyond, let's say, the traditional approach of WAN optimization as a means of accelerating application performance? Because WAN optimization itself, compression and acceleration technology, delivers no value to unified communications specifically. What would be ideal would be if we could take an approach that goes beyond this compression acceleration technique and goes beyond having to have a lot of products, each addressing a single aspect of the environment, to get down to the root of the problem. You need to be able to guarantee business application performance, guarantee that end users get consistent performance, And of course, do so in a way that can be reported upon accountably so that you can prove that the network and the IT infrastructure is delivering the value that the business needs to see. Any approach should also enable new uses of the network, so you shouldn't be constrained and have to go and make a million changes in your environment just because you want to roll out a new application. That is a lot of work and prone to error, as I'm sure we're all aware. So you need to empower the operations teams to take control of the networked environment. Taking such an approach will ultimately protect application investments and put you back in control of the network, avoiding this never-ending cycle of bandwidth upgrades because you've run out of capacity without really understanding what the network is being used for. So, what are the key elements needed in such an approach? Let's have a look. I think the first thing that you need is application visibility. I'm a big believer personally that if you don't know what's going on in your network, you can't manage your network. It's very important that you know all of the traffic that is using your network. Whether it's important or not, you still need to take it into account when you plan to manage the environment. Once we know what's going in the network, we can really take control of it. We can put in place quality of service. We can get hold of the individual user application performance and make sure that the critical apps get the service that they need from all of the resources that are available to us, whether that's the internet or MPLS or however you choose to connect your sites together. Once we've got control and we can ensure that the network is used correctly, that the key applications will always get service, we can apply traditional WAN optimization techniques to the flows where they're applicable to compress file transfers, to accelerate things like CIFS if you're not using the latest version and that kind of stuff. But to do so intelligently, to be able to take intelligent choices about how to divert traffic over the network, to send flows towards the internet where the services reside rather than carrying them over the MPLS network and then doing a centralized internet breakout, to build VPN tunnels between branch sites, to be able to divert traffic, again, intelligently via the internet where it doesn't need MPLS performance. Most businesses will tell you that email is a mission-critical application. I know it is in our organization, but it's not a time-sensitive application. And in actual fact, if it takes 5 minutes to deliver an email, frankly, nobody notices. But if it takes 5 minutes for you to establish a link call, you've got a user who's never going to try and do it again. So balancing the real-time, the transactional aspects of network management with the background file transfer style applications is very, very important, particularly because they are the ones that consume the resources. Now, on top of that, of course, we need to also be able to intelligently plan the evolution of the network, because whilst taking control gives us an instant performance improvement, we're guaranteeing that the network is used for what it was bought for. There will always come a time when we run out of network, but we need to know we've run out of network for a business reason, and as I said earlier, not just because the Olympics is on. Now, specifically regarding unified communications, I think it's fair to say that once the project has been launched, the IT organization becomes very concerned about what the impact of UC will be across the wide area network. Things like, can I turn on video conferencing? What about desktop video? Which codecs am I going to use in the business? How's it going to affect the SAP system at the end of the month? These are all concerns that are very common. And they all need to be able to guarantee voice quality. We need to manage the activation of webcams to make sure that we don't swamp the network with two guys sitting next to each other doing a video conference, for example. We need to understand the impact of things like desktop sharing and collaboration, because they're incredibly useful ways of avoiding travel expenses, for example, but actually they put a big load on the network. And actually, if you're using Lync in the cloud, you've got flows that go in multiple different directions just to achieve any of these particular communications aspects. So while UC has to work, I think it's fair to say we also have to protect those key business applications of ERP and CRM and so on. And not only during the rollout of the Lync applications, but also beyond that, We want to be able to ensure that we get a good take-up, that people are happy with the service that's delivered. And ultimately, we want to manage the performance, manage and monitor the performance both of UC and of those existing business applications. So now I've just got a couple of case studies of people who've actually taken the structured approach to rolling out unified communications into an existing network. And I'll look at the first one, which is a major high-tech company with 10,000 employees. And their key drivers to roll out Lync were really, they wanted to make sure that the users would use it, so they needed to protect it. This is a key thing when rolling out any new service. When it was IPT, it was always that there were always horror stories of people with 3 telephones on their desk and only one of them would work at any one time. We need to make sure that doesn't happen when we roll out Lync. They need to protect their financial and ERP applications so that the business continues to function. And of course, they need to monitor the actual rollout to make sure the service is being used correctly, to try and identify places where it's not successful and investigate why, and to make sure that everybody gets what they need. And by taking the structured approach and by putting in place that visibility, control, and optimization of the network, they were actually able to save 3 million minutes a month of voice time by switching to Lync. That's a massive cost benefit. In the second example, this is an organization that really wanted to optimize their travel budget. They were forever flying chief exec to various meetings and other VPs around the place. And basically, they needed to protect their critical applications. It's an aeronautics company. They were big into moving large CAD files around to be able to build aeroplanes. They wanted to phase out their legacy telephony systems. And they wanted to make sure that what they replaced them with a Lync and Polycom-based telepresence environment was going to be successfully used. And they were able to speed up the rollout both of telephony and video conference by taking a structured approach. And in fact, they reduced their travel budget by 15%. Again, when you take those costs into account, the actual cost of deploying a system that provides these capabilities, it has a very quick return on investment. So how do we run a project to roll out Lync? Well, the first thing to do, of course, is to understand if the network is already in a position to take a new service. It may actually be full of business traffic already. Without visibility, you don't know. So I think everybody agrees the first step is to do an audit, to understand what network resources are available, to understand what applications are already running on the network, and then really to be able to calculate the impact of putting in the expected Lync environment, how many concurrent calls you're going to have, what the cost of presence is across the network, and so on and so on. Once we understand what is actually being done on the network now, we can start to align the network use with the business objectives. So we can categorize our applications into things that are important, things that are not important, things that are real-time, things that are background, file transfer traffic. And we can start to understand whether, again, the capacity exists within the environment. I'll talk a little bit more about what I mean by setting up objectives in a couple of slides' time. The third stage really is to start the deployment, to be able to apply control policies to make sure that the Lync applications get the resources they need alongside the key ERP applications, and that's a key function of having visibility into the environment. We need to be able to check that the applications are behaving correctly and optionally tweak those rules that control how they behave. So there's a little cycle of sort of checking with the users that they're getting the performance that they want on all of the applications that matter to tune up how you expect the network to behave. And then to monitor it and make sure that you're getting good adoption rates. Once you've gone through that, of course, then we're pretty much in a run environment, and it's all about understanding the performance that's delivered, being able to report to show that good performance is delivered, optionally to get into things like charging back for the use of the network if you have a centrally funded network and you want to notionally recoup the costs. I talk to a lot of major multinational organizations who are very in favor of making people aware, not necessarily of actually getting the cash from the different business units, but of making people aware of the real cost of having that facility available to them, so they run a paper chargeback exercise. And of course, once we're in the run phase, we buy businesses, we sell businesses, we add users, we remove users, and the dynamics of the network changes pretty much on a minute-by-minute basis. And we need to be able to plan for the evolution of the environment to ensure it continues to deliver services, but also that it can cater for whatever the next big thing that comes along is. And so understanding how the network is used and being able to report upon that is a really powerful technique. Now, just a quick example of a return on investment. In actual fact, again, in one of the customers who uses our technology, we ran a return on investment study, and we were able to show that for a cost of just about €3 a month, which is $4.50, this individual company were actually able to save €39 on their overall IT costs. And that was broken down into a direct savings of €19 per user on not having to upgrade bandwidth, and €20 per user on reduced IT support, less calls to the help desk, better performance, happier users. And on top of that, the cost of their applications per month per user is actually €300. That's actually a low number, so this must be a manufacturing organization, because the average cost of applications per user is around €1,500 a month. But they were able to protect that investment to ensure that the money they'd spent on those apps was delivering the service that the company requires. Let's have a look a little bit about application performance metrics. Now, if you remember in phases 1 and 2 of my rollout plan, we spoke about understanding what's going on in the network. And the way to measure and control traffic is to be able to identify it. So you need some kind of DPI mechanism to be able to pick out SAP or to understand which web app you're using, to differentiate between people watching YouTube and chief exec video conference, which is probably slightly more important, to be able to understand the codecs that are in use in the voice and video environment and the bandwidth requirements associated with them. And then also perhaps to pick some stuff which, everybody allows internet access in the business these days, but you may choose to say, do you know what, Facebook or Skype or some other application is actually the lowest of the low, and whenever I enter into a busy period, that'll be the first thing that gets a bad service. So I can categorize my applications by what they are, can assign a business criticality. And this is an interesting exercise, having a conversation between IT and the business about what's important so that IT can serve the business better. Once we've done that, we need to be able to assess whether or not the applications work. So we build a technical profile for the application, an SLA, containing things like the expected delay or round-trip time between the user and the servers that the user is communicating with, things like jitter and loss for the real-time applications, and most importantly, how much bandwidth do you actually need per user to make this application usable? In the case of a voice or a video environment, that's a nice question to ask because it's defined by the codec. Even in adaptive codecs, you know how they're going to step up and down in performance. You can assess the bandwidth requirements very accurately. But if I've got a Citrix or a VMware virtualization environment, it's a lot harder to assess, and we really need to do that measurement phase. If I was to go to Cisco and say, how much bandwidth does a user need to run, to Citrix, how much bandwidth does a user need to run a virtual desktop in a Citrix environment, they may say 20 or 30 kilobits. But if that user's watching a video in his virtual environment, it's going to be 5 megs. So you've really got to understand what applications run within the different environments. Once we've built this profile, we can push it out into the network. So we can put devices, probes into the network in key locations where the traffic is, and we can then push this profile out. Then everybody has the same idea of how to manage the network. And here we start to differentiate from traditional router-based quality of service in that we're not having to set each point up individually. We're taking the global approach. Once everything's been pushed into the network through the central management platform in this case, we actually use a sense and respond technique to take the measurements that the system is doing and use them to calculate how to manage the flows to deliver application quality. So this is real-time dynamic application quality. If you start a Lync call, you get real-time guaranteed performance. If you start a telepresence video, you get real-time guaranteed performance. And this is done in a collaborative way, so there's no referring back to central managers or policy control units or anything like that. The devices that you put in the network, they communicate with each other, and they understand how to manage the full mesh of traffic, whether it's internet bound, MPLS bound, however it's going across the network. Let's have a look at a little example. Here we can see without a system deployed, it's quite easy to experience poor video quality. What we did here, this is a lab test we actually did using Lync and some Polycom equipment, and we just set up 2 stations. They were physically right next to each other, in fact, just connected via a wide area network connection. And we ran a video conference, and we can see some interesting things here. We can see when the video conference was the only thing running on the network, performance was fantastic. It got the full 2 megs that it needed. Everything worked wonderfully. You could talk and respond exactly as you would expect. We then started adding in other uses of the network. In this case, we whacked on 10 or 15 web users who were just browsing to the Apple homepage and the Microsoft homepage and YouTube and doing general activity around the web. They instantly sucked up all of the bandwidth. Web pages are actually really heavy things these days. It's not an efficient protocol anymore. There's a lot of embedded objects and streaming media and this, that, and the other in everybody's web pages. And we can see instantly, with no quality of service applied, that the performance fell off dramatically. The video conference that actually required a meg in each direction was only getting 500K. There's masses of latency occurring in the environment, and we're actually experiencing 40% loss. And I think we all know the effect of loss on video conference. It turns into some 1970s disco special effect. So, basically speaking, without some aspect of control, you get extremely poor performance. What could we do about that? Well, there are a range of things we can do about that. We can take the traditional approach of, clearly I've got more traffic than I've got network, I'll buy some more network, which may or may not fix the problem, but it will certainly give the people who use the internet much more bandwidth to consume. That's the way of the world, unfortunately. We could use class of service. We could say, I'll put my video traffic in AF41 and I'll put my voice traffic in EF. And that's fine, again, until you fill the network up, and then you get cascade failures down all your classes of service and everything stops working, which is not ideal. And it's also expensive, actually. You know, if you go and try and turn on class of service, your telco's going to say, fantastic, I can charge you more money for exactly the same thing, unfortunately. You could set up a dedicated network, but again, there's a massive cost associated with that. Or you could try and do WAN optimization. But we all know if you try and do WAN optimization and you don't specifically exclude your real-time flows, you break things even worse, unfortunately. And our friends here at Microsoft actually say WAN optimization and Lync do not mix at all. And we agree. So what can we do about this? Well, Lync itself has inbuilt traffic problem detection mechanisms, and the codecs can adapt. But the penalty of using an adaptive codec is that you get a lower quality than the one that you want. And clearly, with video conferencing, quality is actually quite an important aspect if you're in a room-based video conferencing environment particularly. So it doesn't also manage the competition for flows. You know, I can fail down my video codec, but I'm not actually guaranteeing that my video codec then gets a good quality experience. I'm just making more bandwidth available for somebody else to do something with. So we really need to be getting in and managing that competition rather than relying on individual applications trying to behave correctly. So if we take control of the environment and we put a system in place that enables us to do that, here we've reversed the example. In fact, we've loaded the network up with web traffic in the first instance, and then we're going to put a video conference on top of it. We can see everything's working fine in the networked environment. This is the web browsing traffic flows. We can see standard performance, but when we start the video conference up here, 1 meg, 2 meg video conference, when we start the video conference, we can actually step in and we can say, okay, web traffic is less important than the video conference. We're going to queue that. We're going to deprioritize that traffic to make sure that the video conference gets access to the resources that it needs. And by doing that, you guarantee the quality, you guarantee you get the codec that you're trying to negotiate at the start of the call, and you guarantee that the video conference is successful. And ultimately, do you know what? It doesn't really affect the performance of people's web browsing anyway, because you don't need instant access to everything on a web page all the time. So all we're doing is applying common sense management to the traffic to guarantee that the resources that you have are applied to support the business processes that you've got in place. So why would you choose IPANEMA for Lync? Well, I think the main reason is that we are able to protect the real-time flows and the business applications and add in things like WAN optimization technology at the same time. It's very easy to manage, to centralize your network operations into one single point where you get visibility. You can apply control across the entire network in a consistent fashion. You get reporting. You can use all of the network resources that are available to you. And most importantly, you return the use of the network to the applications it was bought for without denying anybody their fun on the internet at lunchtime. So who are we? Just quickly. IPANEMA, our reason to be really is to be able to guarantee application performance across the network. It's to do so intelligently without the need for a lot of complexity. We like to simplify. We talk about simplexity. It's the latest marketing word. And it's very much about taking that complexity of the environment and making it our problem, not your problem. We're a well-kept secret, although we're used by a lot of major organizations across the entire world. We have a seamlessly integrated product that enables you to start with visibility and add control and add WAN op and add dynamic WAN selection to use all of the available resources, get the reporting and the governance that you require into your IT environment globally, centrally, through a single point. And ultimately, we are proven by a lot of the most complex organizations in the world as being able to deliver those services. So at that point, I'd like to open the floor for questions, ask if anybody has any questions that they'd like to pose about anything that I've said.
Do you interoperate with any WAN acceleration devices, appliances?
Can do, yes, absolutely. If you've already deployed a WAN ops system, because we take a modular approach, you can plug your WAN ops system into our approach, no problem. Yep. It's very common, in fact, that people have gone and they bought whatever product it happens to be, but you still end up having that control problem because once you've done WAN op and you've had your free bandwidth, if you like, you still fill it up at some point and then need to step in and do that management. And in fact, it becomes more important if you've got WAN op because if you go bandwidth upgrade, probably you've got to change your WAN op device and all that other stuff as well. But if you can manage to get the right stuff through the network, you can delay that upgrade for anything up to 3 years just by applying visibility control and path selection, in fact.
Are you an on-prem service, managed service?
Are we on-prem, managed? Yes. We support both, in fact. A lot of telcos will offer a managed service around our capabilities, and you can see on this slide along the bottom a list of the partners who offer managed services around the product. But yes, absolutely, it's possible to do it yourself. Larger, more complex environments tend to like to differentiate between the telco doing it and them doing it themselves. But we support both. Any more questions? Okay, if I could ask you to fill in an evaluation, I'd appreciate it. And thank you very much for your time.